Okay, in this video we're going to continue on 5.2, working with log functions, and today the highlight will be their graphs of the logarithmic functions. So, to sketch the graph of y equals log base a of x, you can use the fact that the graphs of inverse functions are reflections of each other around the line y equals x. So, if I have an imaginary line here, y equals x, inverse functions will be reflections around it. If I have a function that looks like this up here, and I just take all the points reflected on the other side of that line y equals x, it's going to look something like this. So usually the best way to graph a log is to graph its exponential, and then from the exponential stuff, graph the log. So first thing we're going to do, it says in the same coordinate plane, sketch the graph of each function. Part A is f of x equals 2 to the x power. So first let's graph that, and I will use, first let me make my graph a little bigger, and I'll graph the exponential in red. So, let's plug in, this is 2 to the x power. Well, 2 to the 0 power is going to be 1. 2 to the first power is 2. 2 to the second power is 4. 2 to the third power is 8. And then to get our negatives, remember they're sort of fractions or reciprocals of our numbers on the positive side. So if 1 is a value of 2 over 1, negative 1 will be its reciprocal 1/2. If 2 has a value of 4, then negative 2 will have a value of negative 1/4. So let's graph those points. 0, 1 is our y-intercept. Over 1 up 2, over 2 up 4, over 3 up 8. And then the next point there would take us off the graph. So I'm going to start to connect those with a nice smooth red line, kinda. There we go. And on the negative side, negative 1 up 1/2, negative 2 up 1/4, negative 3 would be 1/8, and we're getting closer and closer to the y-axis, or x-axis, but we're never going to touch it. And that just looks terrible at the top. There we go. So this is y equals 2 to the x. Now they're also asking us to graph on the same coordinate axes log base 2 of x. Well, let's see. We just flipped the coordinates. When we graphed in red for the exponential, this was our x up top, and this was our y coordinate in the bottom. Now we're just going to reverse those. So I'm going to graph the logarithmic function in blue, and I'm going to make this my x coordinate, and the top row my y coordinate. So let's see. Now my x is 1, my y is 0. So over 1 up 0. Over 2 up 1. Over 2 up 1. Over 4 up 2. So x is 4, y is 2. And then over 8 up 3. So here's the start of our logarithmic function. And we're headed up that way. And then we also have our points to the negative, 1/2, negative 1. So here we're at a negative 1/2 down to negative 1. 1/4 down to negative 2. And so on. So we're coming down this way. So the blue one is log base 2 of x. Log base 2 of x. And let me see if I got this here. Line. Here's the line, y is equal to x. And the exponential and logarithmic are reflections, like a mirrored reflection across. So, here was, where is it? The point 2, 1, and here's the point 1, 2. This is 1, 2. This is 2, 1. They are reflected about that line. Here is the point 3, 8. Here's the point 8, 3. Again, reflected about that line, y equals x. So that's how you graph a logarithmic function. It's easier to graph the exponential and then reflect to the points. Just switch the x and the y coordinates. So sketch the graph of the common log function, log of x or log base 10 of x. Identify the vertical asymptote. And from the box here, it looks like they're telling us to do some with a calculator and some without. So let's see here. We'll start with the easy one. Log base 10 of 1 is equal to what? Well, log base anything of 1 is equal to 0. That's one of our properties of logs. Log base 10 of 10. The log and the base are the same, so the answer's got to be 1. And if we go to the negative side, we'll have a -1 and a -2. And they're having us throw in a couple there with a calculator. Let me switch colors here to blue. So if we take out our calculator and hit 2 and hit the log key, we'll get 0.301. If we hit 5 in the log key, we'll get 0.699, which I guess I could round that to 0.7. And if we plug in 8 and hit the log key, you'll get 0.903. So let's graph the ones we did not use the calculator on first. First point, 0, 1, or 1, 0, over to 1, up 0, so we're right there on the x-axis. Over 10, up 1. X is 10, y is 1. And then when we go to the negative side, or fractions, 1/10, we're down to -1. 1/100th, we're down to -2. So we are approaching, but again, we'll never touch the y-axis. And we're headed up this way pretty slowly. And our calculator spot should fall on that line. Over 2, up about 1/3. Over 2, up 1/3. Yep, we're right there. Over 5, we should be at about 0.7. Pretty close to 1. Yep, there it is. And if we go all the way over to 8, we're up to about 0.9. Pretty close to the line y equals 1. So there's our graph of the common log function. Just something to note, the exponential always crossed at 0, 1, as we went up, because anything to the 0 power is 1. And when we reflect that about the y, or the line y equals x, we have this intersection point here with our x-axis at 1, 0. That is for the log function. And the exponential function always hits at 0, 1. Y-intercept, x-intercept. The exponential function has an asymptote of the x-axis. The logarithmic function has an asymptote of the y-axis. So the nature of the graph in that in the figure from the previous slide is typical of functions in the form of log base a of x, where a is greater than 1. They have one x-intercept and one vertical asymptote. Notice how slowly the graph rises for numbers bigger than 1. The basic characteristics of the logarithmic graphs are summarized here in the figure. The domain of the log, the numbers we're allowed to put in are just the positives, 0 to infinity. We never go over here into the negative x territory. The range, the outputs, or the y-axis goes from negative infinity to positive infinity. We have an x-intercept instead of a y-intercept, and that x-intercept is at 1, 0. The function from left to right always increases. We know it's a 1-to-1 function. It passes the horizontal line test, and then therefore it has an inverse function. The y-axis is a vertical asymptote. That should be good enough. And here below the picture, the basic characteristics of the exponential function are shown below to illustrate the inverse relationship. So the domain was negative infinity to positive infinity, where in our logarithmic it was 0 to infinity. The range of our exponential was 0 to infinity, when that is the domain of our logarithmic. The domain and the range were reversed. We had an x-intercept for our log function. We had a y-intercept for our exponential. The log has a y-axis asymptote. The exponential has an x-axis asymptote. In the next example, the graph y equals log base a of x is used to sketch the graphs of the functions in the form of some number b plus or minus our log base plus or minus some other number c. Notice how a horizontal shift of the graph results in a horizontal shift of the vertical asymptote. So in example 7, the graph of each function is similar to the graph of log of x. So what do we have here in the first one? G of x equals log of, and now it's not just x, it's the quantity x minus 1. The graph of g can be obtained by shifting the graph of f 1 unit to the right. So in the lighter gray here, which I'll highlight in green, this is our log log function. Cross is at 1, 0. If inside the parentheses, instead of just plain old log of x, what if we do x minus 1? Well, that's going to shift everything to the positive direction. We're going to take this whole graph here that I highlighted in green, and we're going to move it 1 unit to the right. So now my x-intercept is not 1, it's at 2. My asymptote got moved from being the y-axis. Now we have an asymptote at the line x equals 1. So if you play with the number inside the parentheses that you are taking the log of, that's going to be a shift to the left or the right. Now here in the next picture for part B, we have this function. Instead of just, well, we'll start from the beginning here. The light gray one that I'll highlight in green is the log of x. Oop, that was supposed to be green. The log of x function goes through, that was supposed to be green. There we go. It goes through the point 1, 0 and heads up this way. Now we have our log of x function, but this time they're going to put a plus 2 at the front. 2 plus the log of x. Or you might see the log of x with the x off in parentheses, and you might see the plus 2 at the end. I think our book usually keeps the plus or the number at the beginning. So this plus 2, and it's not the number we're taking the log of, if it's a positive, that will shift us up 2 units. If it was negative, that would shift us down. So back to the picture here, in green I did the log of x. If it is 2 plus the log of x, everything gets moved up 2. So I no longer have a y or an x-axis intercept at 1, 0. Now that point has been moved up. It's no longer an intercept, but it just hits the point 1, 2. So if we are not in there with the log function, if it's a number positive or negative, positive will shift us up, negative will shift us down. A couple practice problems. Number 37 and 43. It says find the domain, the x-intercept, and the vertical asymptote, and then sketch its graph. So the first one is just, let me move some stuff out of the way here. Give you a hint on this one. Y equals log base 4 of x. So what we're going to do here is plug in numbers. Y equals, let's write it in exponential format, 4 to some x power. So we're going to set up a little table and find some points. I would go at least from -2 to +2. -2, oops, -1, 0, 1, and 2. You know, find those points for the exponential, and then flip the x and the y coordinates to graph the log function. Let's see here, number 43, we're dealing with some kind of a weird fraction here. This one I would say do all on the calculator. You know, start picking x values. Plug in 1/7, take the log, write down the value. 2/7, hit the log key, write down the value. And on this one, I would plug in x and y values. I plugged in 0, 1, 4, 7, and 8. 0, 1, 4, 7, and 8. That gives you enough points that you can see what's going on with the graph. So pause the video, try to graph those, identify the x-intercept, the vertical asymptote, and the sketch the graph. Alright, here in the first one, since we have it in exponential format, I like to start at 0. 4 to the 0 is 1. 4 to the first is 4. 4 squared is 16. So the negative counterparts are going to be 1/4 and 1/16. And let's graph those points. Well, actually, let's not graph those points. They're just asking us to graph the logarithmic function. So I'm going to switch my coordinates. Now this is my x and this is my y. So let's see. 1 is my x, 0 is my y. The point 1, 0 is my x-intercept. And then I have 4, 1 over 4 up 1 box. And then I have 16, 2 over 16 up 2. That would be way off the graph, but it's going to be somewhere, you know, around that line 2. And then our fractions, over 1/16 and down to -2, over 1/4 down to -1. So it looks like this, and we head over, and we're not very steep at all. Oops, that was terrible. Try that again. Okay, that's a little bit better. There we go. And let's see, the domain. Domain is going to be 0 to infinity. And we can't put 0 in, so 0 to infinity. The x-intercept. The x-intercept is 0, 1. The last thing is the vertical asymptote. Well, we had no shift left or right, so the asymptote is going to be, vertical asymptote is the y-axis. And there we go. Log base 4 of x, there's its graph. Alright, now this one I said you can do on the calculator just by plugging in some values. So this one, we won't have to reverse our coordinates at the end. We can plug in our x's and find our y values that go with it. And I told you to try out 0, 1, 4, 7, and 8. 0, 1, 4, 7, 8. Well, when you plug in 0, you're going to get an error, or if you're on a fancy graphing calculator, you might see a negative infinity pop up. If you plug in a 1, negative 0.845. If you plug in a 4, you get a negative 0.243. If you plug in a 7, you get 0. And if you plug in an 8, now you get 0.058. And let's investigate that 0 a little bit. We plugged in a value of 7. So log of x over 7 becomes log of 7 over 7, or the log of 1. And the log of 1 is 0. So let's graph some of these points. Let's start with the easy one. 7, 0. Over 7, up 0. Over 8, up 0.05. So we're barely off the x-axis. So we are going to be heading up this way very, very slightly. And let's check some other points. 4, we're at negative 0.25. So over 4, down about a quarter of a box. X is 1, we're down to 0.8. So we're over 1, we're almost down to negative 1. Let's see here, 0, negative infinity. We're heading off toward negative infinity, and we're never going to touch the y-axis. So a little different there. Let's see here, domain. Domain is the same. We're going from 0 to infinity. X-intercepts. The x-intercept now is 7. And the vertical asymptote. The vertical asymptote is still the y-axis. And there we go. The assignment for this, page 408. A handful of problems here, 33 to 38, and don't forget 40 and 41.